So number 5 from the simple solids of revolution, revolving the region between 6 minus x squared and y equals 2 around the x-axis. So if we were to revolve that around the x-axis, we're going to get this, like, I don't know, sort of egg-shaped looking thing that's just got a hole drilled through the middle of it, basically. That's essentially what we've got, is an egg with a hole drilled through it. So we need to slice this vertically to give us dx, to give us these cross sections that look like washers or rings or something. And so we will need to integrate pi times the outer radius squared minus the inner radius squared dx from whatever this intersection point is to this intersection point. And so we got to find those intersection points. So we got to figure out when does 6 minus x squared equal 2. Be when x squared equals 4 or x is positive or negative 2. And then we need to find our outer radius. So our radius, our outer radius, measures from the x-axis up to this function, right? If I'm right here, it's this height. If I'm at the origin, it's all the way up to 6, right? But it's only from here to here, which is the height of our function itself, right? It's the height of 6 minus x squared. So capital R is 6 minus x squared. And then little r, the inner radius, is the distance from the x-axis to the line y equals 2. Well, that distance is always 2 units, no matter what. From the x-axis to the line y equals 2, if I go in a straight line up there, that radius, or that distance is always 2. So we should have pi times an integral from -2 to 2 of 6 minus x squared squared minus, I wrote an r there again. I don't know why I didn't write a 2 over here. Said 2 minus 2 squared dx. Everybody good with that? So then 36 minus 12x squared plus x to the 4th minus 4. And 36 minus 4 is 32. So we're going to have 32x when we integrate minus, that'll be 12x cubed over 3, which is 4x cubed, plus x to the 5th over 5 from -2 to 2. And then you just plug it in and evaluate. Is that good for everybody, or do you guys want me to finish evaluating and doing the arithmetic there? Cool. All right, so any other questions on the homework? I'll have the answer key posted up this afternoon. I just haven't had a chance to actually make the answer key yet. So I'll have it up this afternoon. All right, we're going to move on to this problem right here. So I'd like you to take a look at it, read it, and think about why this is different than what we've been doing. So what makes this different from what we've been doing?
It's not rotated on the, it's not revolved around the x-axis.
Right. We're going around the line y equals -1 instead, which actually makes this problem fairly similar to the one we were just working through. Right, we're going to go around y equals -1, which means that this region from 0 to 4, we're going to end up with something that's got, it's going to be like this with a hole through the middle of it again. And the cross sections of it, if we slice it vertically, will still be these washer cross sections in terms of dx. Everybody good with that?
Yep.
Perfect. So we just need to figure out what is the outer radius and the inner radius. We know it should be pi times the integral from 0 to 4. Well, what's our outer radius? Now, instead of measuring from the x-axis, we have to measure from the line we're revolving around. So our outer radius has to go from this point here up to here, or from any value at the height of our function to the line y equals -1. And so what is that height?
The value of the function plus 1.
Right. It should be 1 plus y, or 1 plus 3 root x over 4. That's our outer radius, and it is squared. And what is our inner radius?
One.
It should just be 1, right? Our inner radius is the distance from the line that we are oscillating around to the bottom of our region, which is always 1. And this is how we would set up that integral to find that volume. Does that make sense to everybody? Any questions on that? I won't bother to go through and actually evaluate that one, but good or no? Any questions? Everyone's good? All right. What if I wanted to take y equals the square root of x from, let's say, from x equals 0 to x equals 4, and revolve it around the line y equals -5. So I'm going to take this region and go around the line y equals -5. What am I going to get? Down here, I'm going to get something that looks similar to this, right? And it's just been circled around here with a big giant hole through the middle of it. Good or no?
Good.
Great. So we're going to integrate pi times the integral from 0 to 4. What's our outer radius? What is the distance from the line we're oscillating around to the top of our region?
Square root of x plus 5.
Exactly. It's the square root of x, which gives us the distance from here to here. And that's 5. So it's root x plus 5 squared. And minus, what's our inner radius?
Just 5.
Just 5. And square it with a dx. You should be able to integrate this if I asked you to, right? You just distribute this all out and then combine your constants, which would eliminate the constant actually, and then integrate. Everybody think they could do that? I would hope by this point you could do that. All right, let's do another one similar to this. Let's take y equals, how about, I don't know, the square root of x. And instead of revolving it around y equals -5, let's revolve the region from 0 to 4 around the line y equals 3. So around something that is above it. And so we're going to take this region and revolve it around that line, which means we're going to get some thing up here that looks kind of like that. And down here, we've got like this hole through the middle of it, and the same thing's going on down here. Everybody agree there? It's like
Yeah.
it's like a tube that's got like a volcano looking thing in the middle of it, but the volcano thing is like the hole in the middle of this tube. All right. Well, if I slice it vertically, it's still going to be dx, and it's still going to give me these washers. So it should still just be pi times an integral from 0 to 4 of my outer radius squared minus my inner radius squared. Well, what's my outer radius?
Three minus the function?
So, no. My outer radius has to extend from the line we're going around to the furthest part away of the region. So what is that full distance there? Because the furthest part away from my region is always the x-axis, right?
3.
That's what's further. Yeah, it's just 3. Right, that's my outer radius, 3 squared. Minus, then we got to figure out what my inner radius is. And my inner radius has to go from the line we're oscillating around to the upper bound of my region. The upper bound of my region is square root of x. So this is my inner radius. This piece below it is square root of x. So what does little r equal?
3 minus root x.
Exactly. And there's our interval. Good or no?
Wait, so the shape that's made by rotating it, it still has like straight edges though, right? The curves on the inside.
That's correct. Yep. It looks, if you were just to look at the outside of it, it looks like a cylinder with some sort of hole through the middle of it. Like if you were looking at it from straight on, sort of the way we're supposed to be looking at it here, it looks like a cylinder with a hole in the middle of it. But inside, that hole is starting out at a, super wide, completely wide out here at the very end, and then narrowing out as it goes in to a smaller hole. Does that make sense?
Yeah, thanks.
Mm-hmm. All right, let's do another one. Let's take the region that is between x squared plus 1 and the square root of x. Let's go from 0 to 1. So here's 1, here's that region. Talking about this region right here. And let's revolve it around the line y equals -1. So now what are we going to get? We're going to end up with down here something like this and like this. Right? And it sort of looks like the last one, except now instead of having a flat outside to it, it's got a sort of a beveled, curved outer edge to it. Good or no?
Good.
Okay. So if we're going to go around y equals -1, we got to figure out our outer radius and we got to figure out our inner radius. What should our outer radius be? It's the distance from the line we're oscillating it around to the upper bound of our region. And what would that be?
X squared plus 2.
Yep, it'll be the 1 to get from -1 to the x-axis plus the x squared plus 1, or obviously we can combine those like terms to give us x squared plus 2. And what's our lower radius? It should be
Root x plus 1.
Yep, rho r should be root x plus 1, or plus root x. And so this integral should become the integral, well, pi times the integral from 0 to 1, we said. We'll just say x equals 0 to x equals 1 of our outer radius squared minus our inner radius squared dx. Everybody feel good about that? What if I revolved it around the line y equals 4 instead of around the line y equals -1? What would my outer radius be? The whole distance from here to here is 4, right? But I don't want to go all the way to 4. I want to go to the lower bound of this region, which is how far away from the x-axis?
4 minus square root of x.
Right, we should be going to 4 minus the square root of x. And what should my inner radius be? It should be the height up here that I'm going around, 4, the full thing, minus my other function. Or 3 minus x squared if we simplify that down. And so our integral would be pi times the integral from 0 to 1 of the outer radius squared minus the inner radius squared. Good or no? And obviously you could, distribute all that out in any rate, but you should be able to do that integration by now. So, any questions on any of that so far? So you should be able to revolve around any horizontal axis, whether it's just a line, y equals 4, y equals -1, or if it's the x-axis. You should be able to revolve any region around that and find the volume. You guys feel like you could do that?
Uh-huh.
Oh, good. All right. In that case, let's add to this now and revolve around a vertical axis. So we're going to take that same one that we started with before, and we're going to revolve it around the line x equals 4. So we've got this region going around x equals 4, which gives us this sort of like little chocolate chip looking thing, right? If we revolve this around, we've got a 3-dimensional little piece down here. And if I try to take this and slice it vertically and open it up, what do I get?
Semicircles?
Yeah, I mean, only if this thing here was a semicircle, but it's not. I get some irregularly shaped garbage. Right? I would say it's some sort of irregularly shaped garbage. And slicing it vertically is not going to do us any good. If I slice it horizontally, though, what should those cross sections look like?
Circles.
Yeah, they should be a bunch of circles getting smaller as I go through, stacked on top of each other until we get to the top. Right, so we get circles if we do it in terms of y. And so instead of slicing vertically, we're going to slice horizontally. We'll get circles in the y direction, which means we'll have to do all of our integration in terms of y. So it's still going to be a circle, so it's still going to be pi times the radius squared inside the integral. But now my limits of integration are no longer x values, they should be y values. So I should start at the lowest possible value of my region, which is
0.
Good, and go to the highest possible y value in my region, which is
3.
3. And now we need our radii. So, well, only one for this, because the region that we're revolving around this axis is fully pushed up against this axis. So there's just one radius. There's no holes in the middle of this, right? It's not a washer, it's a disk. So the radius goes from the line we're oscillating around to the left bound of my region, which is my function. Okay, so no matter where I'm at, that's my radius. Well, what is this other distance that's left there? How do we measure a distance from the y-axis to some point? It's always
X.
Exactly. So what is our little radius? If it's this piece and this piece is x, and the whole thing is
Four.
4, then our radius ought to be 4 minus x. And so we should be able to go in and just say 4 minus x dy. Darn, that's a problem, isn't it? I can't do 4 minus x dy, can I?
Nope.
No, and it's got to be squared too. I forgot the squared. Well, I could then go in up here and say, what is x equal? Right? Y over 3 is root x over 4, or y squared over 9 equals x over 4, or x equals 4y squared over 9. Good or no? Everybody okay with that or no?
Yep, we're good.
All right, and that should give us pi. And we'll evaluate this out this time just for fun. 4 minus 4y squared over 9. Distribute that out, gives you 16 minus 32y squared over 9 plus 16y to the 4th over 81. And now we just integrate. So the 16 will become a 16y. What do we have? We have 32y squared over 9, so that'll become 32y cubed over 27. It was minus, right? Yeah. And then our last one, which was 16y to the 4th over 81, ought to become 16y to the 5th over what's 81 times 5, 405. From 0 to 3. And plugging in 0 for the second part of this is nice and easy because that all just becomes 0. So we just need to plug in the 3 effectively. 48 minus 3 cubed is 27. That cancels with that 27. So minus 32. And we had 81 times 5 down here. 81 is 3 to the 4th. So I can cancel 3 to the 4th with 3 to the 4th up here, and leaving me with a 3 times the 16, which is 48 over 5. And 48 minus 12, 48 minus 32 is 16, which is what, 80 fifths plus 48 fifths is 128 fifths. So 128 pi over 5. Good or no?
Good.
Spectacular. All right, a couple more here. Let's see if we can take the region between y equals x squared and the y-axis. So we're talking about this region and revolve it around the y-axis. So if I were to do that, I should end up with something that looks about like that. Would everybody agree with that?
Yep.
Perfect. All right, so then what? Cross sections cut as dy should be circles, shouldn't they? Think so. So all we need is the radius squared. Well, what's our radius? It's just the distance from here to here.
It's x.
It should just be x, but I can't just put in x squared over here, right? Make x squared dy from 0 to, let's see, I didn't give you, let's go from x equals 0 to x equals 4. What does my upper limit need to be if I'm going from x equals 0 to x equals 4?
$16.
Exactly. So we're doing this in terms of y. So how do we turn x squared into a term of y? Well, we just need to look at this and replace it. So we have pi times the integral from 0 to 16 of just y dy, which ought to be pi times y squared over 2 from 0 to 16, which should be easy enough. The 0 is 0, and the 16 squared is 256 over 2 is 128 pi units cubed. Good or no? All right, let's say something like y equals root x. And let's go from, how about from 0 to 4? That's what we were doing before. But let's revolve it around the y-axis. What do I get? I get washer cross sections, don't I?
Yep.
So this should be pi times something with dy. What's the lowest part of my region?
Zero.
And what's the highest part of my region?
Two.
So pi times the integral from 0 to 2 of my outer radius. Well, what's my outer radius? It's always going to go from the line I'm oscillating around to the furthest right portion of my region. So I'm oscillating around here, going all the way over to here. What is that distance?
4.
It's just 4. 4 squared minus my inner radius. Well, what's my inner radius?
X.
It's the distance from here to here, or just x, exactly. X, which x equals y squared, right? So we should have 4 squared minus y squared squared dy. And what does that give us? Pi times the integral from 0 to 2 of 16 minus y to the 4th dy. Which should be pi times 16y minus y to the 5th over 5 from 0 to 2. And what do we get if we do that? We get pi times 32 minus 32 fifths. And minus 0. And then let's see, common denominator there makes that 160 fifths minus 32 fifths is 128 fifths. So 128 pi over 5. Popular number 128 today. Good or no?
Amazing.
It's great. The difficult part will be finding what your outer and your inner radii are. The easy part is once you plug it in anyway. The hard part is the setup and being able to label and draw your picture properly. So we're going to do one more. This will be the most difficult one we do. We're not going to actually evaluate it all the way out because we won't be able to. But we're going to see if we can set up an integral that will give us we're going to take y equals e to the x from x equals 0 to x equals 1 and revolve it around the line x equals 2. So e to the x we know looks like this, and at 0 it has a value of 1. And over here at 1 it hits a value of e. And so this is the region that we are looking at here. And we want to take that region and move it around x equals 2. So we're going to get something about like that. Good or no?
Good.
Great. So first off, is there a cross section slicing it horizontally in dy that is a circle or a washer, a disc or a washer?
Yeah.
Yeah, we get washers, right? We should get these washers every time. Now, second question is, when we look for the inner radius, is there always one specific function that bounds the right-hand portion of this region, right? Because we have our line that we're oscillating around, revolving around is to the right of our region. So the inner radius should come from the rightmost bound of our region. And there's one function that represents the rightmost bound of our region, right? It's x equals 1. And what is that inner radius always equal to?
1.
It's always 1, right? It's always the distance from 1 to 2. Now, when we talk about our outer radius, is there one function that bounds the left part of our region for all of the y values from 0 to e? Does e to the x always bound the left part of that region for all y values from 0 to e?
No.
No, sometimes there's this vertical line that does. So our outer radius is a little more complicated. It's got two different functions to bound it. And so we have to split it at the place where we change from one bound to the other. So we're going to do pi times an integral from 0 to 1 dy plus pi times the integral from 1 to e of something dy. Everybody conceptually understand why we've got to split this one up?
Yes.
Okay, so from 0 to 1, what's our outer radius? From y equals 0 to y equals 1.
1.
No.
2.
2. But from 1 to e, well, we've also gone over this x amount. And so what is the radius? Should be the full 2 minus x. And what is 2 minus x? Well, we need x to be in terms of y. So x should equal natural log of y. Everybody good with that? So our outer radius is 2. So 2 squared from 0 to 1 minus inner radius of 1 squared. That's a really easy one. And then this one, outer radius is 2 minus ln y squared. minus 1 squared. And this would be the set of integrals that we would use to find that volume. And you'd have to use a calculator to approximate that because you don't have, we never learned a rule for natural log of y because that requires integration by parts, which is a Calc 2 thing, which you will learn next year if you take a second semester of Calc. Any questions on that one? That one's a little bit more difficult. This is about as difficult of a problem as I might give you for the setup, right? I mean, I might give you one where you can actually integrate it, but I won't give you anything that's probably more difficult than this is to set up. So something where there's multiple different radii that you have to deal with for your outer or inner radius, as well as revolving around a vertical line so that it's terms of y, as well as that not just being the y-axis where it's actually a distance away from it. That's about as difficult as they'll come for our purposes. Any questions on anything we're going or that we have done today? Because that's the end.